Geometry Trig Honors, Lesson 7.5, Sum and Difference Formulas. So this is a fairly large lesson. And it won't have any proofs, but it'll show you how to apply these formulas. Once again, in trigonometry, we'd like to get a little bit more exact. We can do cosine of 45, and we can do sine of 60. Had a moment where I froze. How about cosine of 75? And you might say, well, it's not on the unit circle. And okay, it's not on the unit circle, but you know what? We got some really cool formulas. They're called sum and difference formulas. They're derived on the unit circle, so if you ever want to look them up, they're really not that bad. I just don't have time here. The formulas work where you have cosine. If it's positive, then it'll be negative. If it's negative, it'll be positive. Sine stays the same for both. So let's find cosine of 75. Well, what adds up to 75? So the first step I usually do is say, well, that's 45 plus 30. This is kind of my alpha. This is kind of my beta. And cosine of 45 plus 30, and I'm going to throw the degrees out just in the interest of time because it'll take forever. That equals cosine of 45, cosine of 30, remember the signs switch, minus sine of 45, sine of 30. Cosine of 45 is root 2 over 2. Actually, I'm going to move this down here. So that gets us root 2 over 2. Cosine of 30 is root 3 over 2. Root 2 over 2. Sine of 30 is 1/2. Apologize for the handwriting, but I do need to keep moving here. You're going to see this combination more often than you'd care to admit. Root 6 minus root 2. Root 6 plus root 2. Negative root 6 plus root 2. Negative root 2 plus root 6. Check it on your calculator. I'm not going to, again, in the interest of time. Put in cosine of 75, make sure you're in degrees, and then put in this formula. You'll get the same thing. Now, pi over 12, a little trickier here. Pi over 12. How did I know that pi minus 3 minus pi over 4 off the top of my head? Well, I practiced. This is 4 pi over 12, and this is 3 pi over 12. Subtract them, and hey, I'm there. So, sine pi over 3, cosine of pi over 4. We're subtracting, keep it the same. Cosine of pi over 3, cosine of pi over 4. What if you use something different? It's going to work. What if I use something different over here? It's going to work. What if I did a subtraction over here? It's going to work. Has to. So don't get hung up on, I'm not sure if this is the right one. It's going to work. Warned you about this. Oh, look at that. Root 6 minus root 2 over 4. So I was told this leads to the following identities, and hopefully I've memorized these well enough. So establish them. Cosine of pi over 2, cosine of theta, plus, because cosine flips, sine of pi over 2, sine of theta. I'm just going to write that one out right here. Cosine of pi over 2 is 0, so the first term is 0, plus sine of pi over 2 is 1 times theta, gives us sine 1 times sine of theta, gives us sine of theta. Quickly on the other one, wrote it down, might as well do it. Sine of pi over 2, cosine of theta, minus cosine of pi over 2, sine of theta. Again, we get cosine of theta minus 0 cosine of theta. So we'll be doing this. We'll be using more tools to establish identities. Try these, see what you can do with them. This one's one of my favorites, sine, cosine, cosine, sine. Hey, that looks like sine of 80, sine stays the same, minus 20, equals sine of 60, and I know that's just root 3 over 2. Plug all this into your calculator. Hey, look, I got the same answer. Cool. 7 pi over 12, that's going to be 3 pi over 12 plus 4 pi over 12, aka pi over 4 plus pi over 3, sine of pi over 4, sine of pi over 3. We're adding, so keep it. No, sine goes cosine. Sine, cosine, right. And that is root 2 over 2, 1/2. Holy mackerel, this looks familiar. Root 2 over 2, root 3 over 2. I feel like writing the root 6 first. No, you don't have to. Over 4. Cool. So let's mess with you. Given sine of alpha is this. Do this one in red. We are in the second quadrant. Alpha. Sine is 4 over 5, negative 3. Thank you. I'm going to go with green over here. Sine of b equals, bad teacher, did not write in the quadrant. Does it matter what quadrant? Third Q. Naughty, naughty, naughty. Beta. Notice alpha and beta have nothing to do with each other. We have to set up 2 whole problems. What a pain. Negative 2 root 5. Get out of the way. Negative 2 root 5 over 5. Negative root 5, I think. 5. This is 4 times 5 is 20. 20 plus 5, 25. Booyah. I find it very useful to do this. They gave me sine of beta, so let's go with cosine of beta is negative root 5 over 5, and tangent of beta is 2, I believe. I'm going way too fast on these problems. I would never do these fast if I was doing an assignment. Cosine of alpha is negative 3 over 5. Tangent of alpha, I don't need the tangents now. I would need them later for these problems, but we're only doing these. So there's cosine of alpha, there's cosine of beta. And now, let's do cosine of alpha plus beta. Yeah, we'll write it out. Equals cosine of alpha. You know what? Write it out. Cosine of beta. Flip the sign. Minus sine of alpha. Sine of beta. Cosine of alpha. Negative 3/5. Cosine of beta. Negative root 5 over 5. Minus. Boy, I hope I'm doing the right formula. Well, I'll find out in a minute. Sine of alpha, given in the problem, 4/5. Sine of beta, negative 2 root 5 over 5. Shockingly, we have a common denominator. And we will have all the negatives in the world cancel out. 3 root 5 plus 8 root 5 is 11 root 5 over 25. How did I do? Hey, I got it right. Man, I'm impressed with myself. Running out of space here. What else is new? Sine of, that was hideous. Purple, I said purple. It's a little bit less hideous. alpha plus beta sine of alpha sine of beta plus, no, that's wrong, cosine alpha cosine beta equals 4/5 cosine of beta negative root 5/5 cosine of alpha negative 3/5 cosine of beta, nah, I keep it right, sine cosine cosine sine, naughty me, negative 2√5/5. Negatives cancel. 6, 4. Looks like 2√5/25. Cool. Got another one right. So very, very detail oriented. Lots of time on task. Very challenging. Gonna have to work hard on this, just like on trig identities. Can we use this to verify a trig identity? What a coincidence. It's right there. Yeah, but the nice news is this gets really easy because, I mean, it's telling you almost right there what to do. Cosine alpha, cosine cosine, flip the sign. These are going to cancel here and here after I divide them on the other side, and cosine alpha over sine alpha is cotangent of alpha. Cosine beta over sine of beta is cotangent of beta. These two together make 1. Hey, look at that, I'm done. So I just think these are much easier trig identities. So that was supposed to be about it, but I totally skipped tangent, which I would have introduced up front, but I'm following our textbook so that people don't get lost. It's done differently, so keep your eyes open. 5 pi over 12 is a pain. I always forget how to do it. I've actually converted it to degrees and then figured out, oh wait, that's pretty obvious. So actually, yeah, I believe it's pi over 4. Nope. Oh yeah, pi over 4 plus pi over 6. Where you been, pi over 6? So tangent of 5 pi over 12 equals tangent of pi over 4. Sine stays the same. Tangent of pi over 6. 1 sine flips. Tangent of pi over 4. Tangent of pi over 6. This may be a moment in time that a few of you are saying, boy, I really should have paid attention to that unit circle thing. Only if I had told you. Only if I had told you. But I guess I forgot. 1 plus root 3 over 3. And I'm going to change that immediately on the fly. 3 over 3. Let me just make sure I did that right. Sine, yeah, that's right. 1 minus root 3 over 3. Oh, I'm going to change this one on the fly too. Hopefully you see I can get rid of all these. And this is what stinks about tangent. It feels like you're never really done. We got to multiply by the conjugate. Kind of in a rush to get this done, just running out of time. The base is 6. The top is 12 plus 6 root 3. So when all is said and done, we get 2 plus root 3. I've seen that answer more than a few times. I want to make sure I did that right. Yep. You can also use this to prove things. All we do is blast it out. This would be a plus, so we get tangent of theta plus tangent of pi over 2 which, if I'm not mistaken, is undefined. So how the heck am I supposed to do that? Very upsetting when I run across a problem that I thought I prepped for, and it doesn't actually show up. Yeah, so we can't use this formula, which is good. One of these is in the homework. But we can use sine of theta plus pi over 2 over cosine theta plus pi over 2. The only problem now is I didn't leave nearly enough room. Sine of theta cosine of pi over 2 plus cosine of theta sine of pi over 2. Something's got to cancel here. Cosine, that's going to go. Sine of pi over 2 is going to be 1. Cosine of theta cosine of pi over 2, see ya, minus sine of theta sine of pi over 2, 1 equals negative cotangent theta. Cool. I apologize for my homework problem that I did in a very different manner than that. Now this will freak people out. It's challenging. It's not impossible, but it's going to make you work for it. So we need to find the angles. I'm going to consider this my alpha angle over here. So I'm going to really change up colors here. Let's go with green. And I don't know anything, so might as well put it in the first quadrant. Cosine of this alpha is 1 over 2, and that makes this root 3. And then this one over here, again, doesn't say what quadrant it's in, so might as well put it in first. Well, actually I have to because it's an arc sign, that goes first. The positive arc sign, so it goes first. This will be my beta. Sine is 3 over 5 and 4. So I know what sine is. Cosine of beta is 4 over 5. And sine of beta, alpha, is root 3 over 2. So here we go. Sine of alpha. I'm adding two things. Sine, cosine. Cosine beta. Keep the sign the same. Cosine of alpha. Sine of beta. So let's blast them in. Root 3 over 2. 4 over 5. Plus cosine of alpha, 1/2. Sine of beta, 3/5. Equals 3 plus 4 root 3 over 10. That's crazy math. I tell you what, that is out there. We can write things as an algebraic expression. Exact same thing we just did. I'll call it alpha just because it's easy. Sine is u over 1, so that makes this square root of 1 minus u squared. You can check that if you're not sure. It works. And the other side is cosine of b. So I'll call this my beta. V over 1 minus v squared. And then it's sine, so it goes sine alpha, cosine beta, same sign, cosine alpha, sine of beta, sine, cosine, cosine, sine. Sine alpha is, that was easy, u over u. Cosine is v, and now is where things get a little bit different. Cosine of alpha is root 1 minus u squared. And sine of beta is root 1 minus v squared. Don't try and put them together. We're done. So I mean, that's out there. That's some crazy, crazy stuff. And last but not least, let's go solve an equation. This is very weird. We're going to square both sides. Sine squared theta plus 2 sine of theta cosine theta plus cosine squared theta equals 1. Cancel, cancel, cancel. Hope you know why. So either sine of theta equals 0, theta equals, right, 0 or pi, or cosine of theta equals 0, theta equals pi over 2, 3 pi over 2. Well, we got to go check for extraneous because we squared both sides. When you do that, that sort of thing happens. Sine of 0, no problem. Cosine of pi, cosine of 0, 1, that looks good. This doesn't because it's negative, and I'm betting this 2. Pi over 2 is 1, good, and that's negative, so you had 2 extraneous values. These are your answers, 0 and pi over 2. We could do this a different way, but it would make us literally insane, so we're not going to do that. They do this really crazy stuff to create a sum and difference formula, and yeah, I'm not having any of it. So, boy, is that a lot of math. Happy mathing and good luck.